So previously we were using the substitution technique where I was giving you the value for the substitution variable, the u as we call it. Now we have to decide. So I want you to look at this integral here, and I want you to decide what should the u be. The u should be right now the inner function of a composition. Do you see a composition? Do you see an inner function? I hope you see the inner function of x squared plus 1. It's inside the cubing function, right? U cubed. So that should be your u. The inner function is x squared plus 1. All right. Now what do? I take the du to find the derivative, right? The du dx is going to be just the derivative of this is 2x. So du is 2x dx. Now, when I look here, I've got a 3x dx. Okay. Now, there are several ways you can proceed on this. Again, as I said, you could factor out, pull the constant multiple 3 out, and then you have an x dx, and to get an x dx, I multiply both sides by 1/2. I like to just get the 3 here. How do I get a 3? How can I multiply anything times 2 and get 3? Is that possible? Yeah. Multiply by 3/2, right? 1.5. 3/2. So if I multiply both sides by 3/2, I get 3/2 du here, and 3/2 times 2 is just 3x dx. That's the way I like to do it. I like to balance everything out there so that I know I got everything covered. I got the 3x dx covered here. That's the 3/2 du, and the x squared plus 1 cubed, that's just going to be the u cubed. And so with that substitution, I'm ready to proceed. The 3x squared plus 1, that's u cubed, and the 3x dx is the 3x dx is what? The 3/2 du. What I typically do now is after I get the 3/2 du, I pull that 3/2 out. So I'll just pull that 3/2 out now and write the du there, and I've got everything covered. Now I've got a simple integral to do, right? The antiderivative of u cubed, got this 3/2 here, don't forget. Antiderivative of u cubed is what? 1/4 u to the 4th plus c. And now we're ready to write it in terms of the original variable. U is equal to x squared plus 1. 3/2 times 1/4 gives me 3. 2 times 4 is 8. U is what? X squared plus 1 to the 4th plus our constant c. And again, I want to encourage you, take the derivative of this using the chain rule and see that indeed you get this function here. Every time you do this at the beginning, I would do that, and later on, to encourage you to be able to check. You can check that you found the right antiderivative just by simply taking the derivative and make sure it is indeed what you started with. On quizzes and on tests, if you have time to do that, I would do that. I would definitely do that. In fact, let's just do that real quick, right? Let me just check. I'm going to do it. I'm going to take the derivative with respect to x of 3/8 x squared plus 1 to the 4th. You can put plus c in there, but of course, what's the derivative of a constant? 0, right? So that's going to go to 0. All right, so notice I've got chain rule here. I've got a constant multiple rule. 3/8 is a constant multiple. Pull that out. And then you got chain rule, right? X squared plus 1 to the 4th. So remember how we do that. We take the derivative of the outer function, which is u to the 4th. So that's going to be 4u cubed, and u is what? The inner function, x squared plus 1, all right, times the derivative of the inner function, which is 2x, right? So this is by the chain rule. Okay. And if I clean things up a little bit here, what do I get? Notice I've got 2 times 4 here. 2 times 4 is 8. 3/8 times 8 is just 3. I've got my x, and then in parentheses x squared plus 1 cubed. Is that indeed the original function we started with, 3x times x squared plus 1 cubed? It is. And so I have been able to check and confirm that that is good. So I would encourage you to do that as well. Okay, let's take a look at a few others here. This is, whoops, hopefully a pretty simple one. I want you to choose the u. Notice our independent variable is r. We'll again let u be our variable. What's your u going to be here? I hope you're choosing 2r minus 1. I mean, there's not much else to choose, right? That's inside the square root function. right? Now what is du? Du is derivative of 2r with respect to r is 2 dr. All right. Now look here, I just have a dr. I have 2 dr. So how do I get a dr? I multiply both sides by half. 1/2 du, 1/2 times 2 is 1 is dr. Right. And now I can replace everything. I've got the integral. Square root of 2r minus 1 is the square root of u. And then times the dr, which is the 1/2 du. Pull that 1/2 out. Of course, u to the square root of u, I'm going to write as u to the 1/2. And so I get 1/2. Antiderivative of u to the 1/2 is 2/3 u to the 3/2 plus rc. And now replace u with the 2r minus 1. Of course, 1/2 times 2/3, the 2's right cancel. I'm left with 1/3. U is 2r minus 1 to the 3/2 plus c. There's our antiderivative. Again, you can check and confirm that this is the case, that this indeed is the antiderivative of that. Okay, now let's move on to number 7. Notice here the original variable in the integral is u. That means you must choose some other substitution variable than u that we normally do. So let's try t. So I want you to think about what's the inner function here. And there's lots of functions. There's actually a couple of compositions here, so it might be a little tricky, and there may be more than one answer maybe. But again, when you're doing substitution the first time and you encounter something like this, try something. You know, if it helps, then good. If not, you might need to do something else. So I'm going to start here with this. You might say, okay, cosine of 3u, of course, sine squared of 3u is really what? Sine of 3u all squared. Okay. Now, so you see a couple of compositions, but maybe some of you might say, hey, I see, what if I let t, that's our variable we're going to use, be equal to the 3u, because that's inside the cosine function. It's also inside the sine function. Yeah, that's a valid thing, right? That's a good choice maybe. And what's the dt? It's just 3 du. Yeah, I like that. That's pretty simple. Now I look and I just have 1 du. These 3's cannot be factored out, so I have just 1 du, so I need to do what? 1/3 dt is equal to du. And with this, then here becomes my integral. I've got the integral of sine squared of just t, right? The 3u is t. And remember that sine squared again, this means what? This is sine of t all squared is what that means. Times what? Cosine of t. And then the du is what? 1/3 dt. So I'll pull that 1/3 out and I'll be left with dt. Okay, so there it is. But now we look at this integral and well, what's the antiderivative of that? Well, that's, I don't know. Didn't seem like substitution helped me out here. I don't know what the antiderivative of sine squared of t times cosine of t is. Again, I can't just take the derivative of these and multiply them or something like that. So you might say, hey, well, I could choose here inner function of sine of t, right? Inside what? The squaring function. Yeah, you can do a substitution again. So maybe I choose w to be that inner function sine of t. Then what's the derivative of the sine function? That's cosine, right? So dw is cosine t dt. And guess what we got there? Cosine t dt. Hey, we've got exactly what we want. And don't forget our 1/3. So this then becomes what? 1/3 integral sine t squared. So that's w squared. Cosine t dt is just dw. And hey, now that worked, right? That cleaned things up. W squared is easy to find the antiderivative of that. The antiderivative of w squared is 1/3 w cubed plus c. And so what do I get? I get 1/9. And what is w? W was what? Sine of t. So it's 1/3 sine of t cubed plus c. You say, we're done. Well, not quite. Remember, the original variable was u. We've got it in terms of t, but that's easily rectified because what is t? T is 3u. So now I get 1/9, and sine t cubed is sine cubed t, so this would be 1/9 sine cubed t is now the 3u plus c, and that is the antiderivative. And that is the antiderivative of the original, right? Again, if you take the derivative of this, you'll get back to this. Now, some of you might be saying, wait. There was another choice that you should have made for the inner function, and you're right. If you go back to the original, when we looked at this sine squared of 3u, it's sine of 3u inside the squaring function. What if we choose our inner function t to be sine of 3u? Well, if you did that, you will do both of these steps essentially in one, and that's fine. But if you didn't see it, it's okay. I mean, you might have to do a substitution again, or you might go back and try something that like this. So here's or. I can choose t to be the entire sine of 3u. Now, because of that, we're going to, when we find the dt, be using the chain rule, right? This is chain rule, right? Sine of 3u. Inner function is 3u, outer function sine. So the derivative of the outer function sine is what? Cosine, evaluated at the inner function 3u, times the derivative of the inner function here, which is 3. So this is 3 times cosine of 3u du. Okay. Kind of break that up from what we had over here. We were doing it. Okay, so now going back to the original integral, I've got sine of 3u, right, squared, but sine of 3u is my t, so that's t squared. And I've got 3, right, cosine of 3u du. If I look up here, I've got just 1 cosine of 3u du. And here I've got 3 cosine of 3u du. So what do I need to do this equation? What do? Multiply both sides by 1/3. So 1/3 dt is cosine 3u du. And so the 1/3 dt goes here. So I'm going to do the 1/3 pulled out of the integral. And there it is. In one step, we get that simple integral. And same one we got here in 2 steps, right? So really what we're doing here, this one substitution is combining the 2 that we did here. The antiderivative now, 1/3 t cubed plus a constant. And when we plug in back for t, this becomes 1/9 t cubed. If I replace t with sine of 3u, we get right back to what we got in the previous attempt, right? We're going to get the exact same thing. Okay, so again, sometimes it's not quite clear. You know, we got several substitutions. What do we use? Don't just give up. You know, try something and see if it will work. Try something and see if it will work. Okay, we're going to stop this video here and we'll do some more. And this is really a skill that you need to work at because there's so many variations of this. So you can see how they get a little bit more involved. All right, so we'll look at some more in the next video.